Hello everyone, in this video we will learn about the third lab program of the subject Digital Design and Computer Organization. The question is, design Verilog HDL to implement binary adder subtractor, half and full adder, half and full subtractor. Half adder design is a combination circuit that perform 2-bit binary numbers. Means here we have to give two inputs and the output is carry out and sum. A, B are the inputs of four combinations. The sum we get is 0 plus 0 means 0, 0 plus 1 means 1, 1 plus 0 means 1, 1 plus 1 means sum is 0, carry out is 1. For this we have to write the expression sum S is equal to, for when sum is 1, the inputs are A not B. When sum is 1, the inputs are A, B not. So here it is, and the carry out is, when carry out is 1, the inputs are A, B. Sum can also be written as in the form of XOR gate. This is the symbol of XOR gate. Here two are inputs A, B, and we have to write the diagram for this expressions. Sum is equal to A, B naught plus A naught B. Complement means we have to write NOT gate, A, B naught, one AND gate, A naught, B another AND gate. Output of this AND gate are the input to the next OR gate, and this is the sum expressions, and carry out means A, B, that is single AND gate. Next is full adder design. It's a combinational circuit that perform 3-bit binary numbers. Here 3 inputs A, B and carry in. Output are carry out and sum. And inputs are in 8 combinations. When sum is 1, it means A, B carry in. If any of this is 1, then sum is 1. Carry out we get 1 when A, B carry in. If any of this 2 value is 1, then we get carry out as 1. If both A, B carry in are 1, then carry out and sum both we get as 1 output. Next is KMAT for sum and carry out. Sum means there are 3 inputs A, B carry in. A, B are in 4 combinations. Carry in are in 2 form 0 and 1. When sum is equal to 1 means, when sum is 1 here, A0, B0 carry in 1. So A0, B0 carry in 1. So in this place we have to write it as 1. Like that we have to fill the K map. Next is carry out. That is also same. When carry out is 1 means A0, B1 carry in 1. A0, B1 carry in 1. In this place we have to write 1. Like that we have to fill the K map. But in sum we won't get any pairs. We get single terms, but in carry out we get 2 pairs, means that is in 3 form. So this is sum expressions because there is no any, because we can't do any pair here, but carry out is one pair is A, B, and the next another is A carry in, A carry in, and the next is B carry in. So 3 terms we get here, and the next we have to write diagram, gate diagram for this. Here there are 3 inputs, therefore we have to use 2 XOR gates. 2 XOR gates here we have written, and the next is carry out. For these expressions we have to write, first is AB, one AND gate. Next is A carry in. A carry in is another AND gate. Next is B carry in. B carry in is another AND gate. This output of this AND gate are input to the next OR gate, and the output of next OR gate and AND gate are input to the next another OR gate. Like this we get carry out as output. Next is half subtractor. This is same as half adder, but we have to do subtraction here. 0 minus 0 means 0. 0 minus 1 means difference is 1. Borrow out is also 1 because we are subtracting from lower value to higher value. 0 minus 1 means we get borrow out also 1. But 1 minus 0 we get difference 1 but not borrow out. 1 minus 1 means borrow out also 0, difference is also 0. So difference expression is, when difference is 1 means x bar y plus x y bar for this two ones. And next borrow out means, borrow out is 1 means x bar plus x bar into y. Or already we know we can write difference in form of XOR gate. Here the diagram for this is means bar or complement means we have to use NOT gate, x y bar one AND gate, x bar y another AND gate. Output of this AND gate are input to the next OR gate. Next is borrow out. Here we get x bar y is one AND gate. Next is full subtractor. This is same as full ladder. Here we have to give 3 inputs and borrow out and difference are output. Difference is same. If x, y borrow in any of this is 1, then we get difference as 1. But for borrow out it is quite different, because if x is 0, y is 0, borrow in 1 means we can't subtract 0 minus 1. We get borrow out as 1 because we are subtracting from lower value to higher value. This is also like that. 0 minus 1 means we get borrow out as 1. Here also same. 0 minus 1 means we get borrow out as 1. But not for this 1 minus 0, we won't get as 1. Here we get as 0. So, and last one is 1, 1, 1. When x1, y1 and borrow in 1, we get borrow out and difference both are 1. And K-map for difference and borrow out. This is same as full ladder. When difference is 1 means x0, y0 borrow in 1. x0, y0 borrow in 1. Like this we have to fill the K-map, but we won't get any pairs. We get single terms. In borrow out, x0, y0 borrow in 1. x0, y0 borrow in 1. Like that we have to fill and we get 3 pairs. So we have to name difference for single terms, or we have to name it as using XOR gate. Here there are 3 inputs, so we have to use 2 XOR gates. And borrow out expressions is x bar borrow in 1 term. Next is y, that is changing, that's not changing from here to here. So this is y borrow in, and the next last is x bar y. And the gate diagram for this expressions, this is XOR gate. Here we have to use 2 XOR gate because we are taking 3 inputs. And borrow out diagram, x bar borrow in x bar borrow in 1 AND gate. Next y borrow in another AND gate. Last is x bar y means we have to use NOT gate here. And the output of AND gate are input to the next OR gate. Output of OR gate and AND gate are input to the another OR gate. Like this we get borrow out diagram. And the next we have to write is Verilog code for half adder and subtractor module. And next is half AS means here we have to give, we can give any name, and inside this we have to write inputs and outputs. A, B are inputs, sum, carry, difference, borrow are outputs. Here we have to write it in separate input by using input and output keyword. Next we are writing here data flow level program. First is assign sum. Sum is here we are using XOR gate symbol. A XOR B means K, B are the inputs. Next is assign carry. Carry get means we get here A, B. That's why carry out. And next is borrowed X bar Y. So first is AB and the next is X bar Y. Here we are taking AB. So A bar B. And the difference and sum is same because we are using the XOR gate. And carry and difference is different. And end module. Like this, we have to write the Verilog code. By giving inputs to A and B, we get the output as like this. For sum, carry, difference and borrow in the Xilinx software. Full adder and subtractor Verilog code means module. First module we have to name this as something like anything we can give. Inside this we have to give the inputs and output. Inputs here are A, B, C. Sum, carry, difference, borrow or outputs. Here we have to use that in using input and output keyword. Next is assign sum and assign difference is same because here we used XOR gate. So 2 XOR gate and 3 inputs. Carry and difference we have to write according to the equation we get here. This is one equation for borrow out full subtractor and another is this is carry out full expressions. AB, AC, BC. One is for full adder and another is X bar B, Y bar B plus X bar Y. This is we have written in by using logical operators. Last is end module. Like this we have to write the Verilog code. By giving inputs to the A, B, C, we get the output as like this. Sum, carry, difference, borrow in Xilinx software. Like this, we have to write the Verilog code and we have to check. Thank you.